let's go through these little warm-up problems. We'll go through any questions you may have. Anywhere, we will finish the last lesson today, okay, which is more vocab stuff. So, for number 2, the graph represents the length of time a class did a practice together in minutes. Data of multiple classes was collected. Answer the questions using the graph. So this was frequency. It was kind of cut off, but that's how many classes fell in the bucket. So what type of graph is this? Danielle? This is a histogram. Good. Okay, approximately how many classes were polled? How many classes were polled? Go ahead, Liam.
Probably incorrect. I said 105 classes.
105 classes. Yep. Good. Okay. How many classes did practice together between 15 and 20 minutes? Wes? 25 classes. Good. Okay. How many classes did practice together for over 30 minutes? Sabrine? 15. Okay. Is this graph symmetrical, skewed left, or skewed right? Louise? Skewed right. Because we look at the tail over there. What is the relationship between the mean and the median? Assad? Good. The mean is greater than the median. Awesome. Okay. Good. All right. Then we have this guy here. All right. What type of graph is this? Taylor. It is a dot plot. Good. Okay. How many kids were polled? Sawyer? 15. Awesome. Okay. How many kids have over one sibling? Brayden? 10. Good. And 3 siblings or less? Addison? 13. Good. Is this graph symmetric, skewed left, or skewed right? Genevieve? Symmetrical. Good. What's the relationship between the mean and the median? Grace? Mean is equal to the median. If we had to approximate, what is the mean and median? Looking for Rosanna. 2. Okay. Looking at it, should be 2. Good. How many of you did get these first 2 correct? Okay, great. All right. Now we're looking at, honey, this is the first box plot that we've seen an outlier being represented. Okay. This means there's an extreme outlier, hence with this little asterisk here. Okay. That is your outlier. So, what is the 5-number summary? Say and go ahead. Careful. It would be 80. Even though it's not included, there is a tool in your calculator. If we did the 5-number summary, this would come up, right? If we were to graph it using our calculator, there is a button we could press that shows those extreme outliers, okay? It's still calculated as the maximum, but might not be on that whisker, okay? What is the range and the IQR? So what is the range of this data? Esteban. 28 and the IQR is 9. So remember, the range is your max minus your min, and the IQR is quartile 3 minus quartile 1. Okay? Is this data skewed or symmetric? Pairs. Good, skewed right. Anytime we look at a box and whisker and have to determine if it's skewed left or right, we go from the median, just like if we were to look at a histogram or even a dot plot. Okay, you're looking for the center. Yep. In this scenario, no, just for practice, I want you guys to get into it. Typically, if I ask it, it's going to be skewed right, left, or symmetric. Okay. Are there any outliers? Danielle? 80. Good. Okay. What percent of the hives brought in 56 or more pounds of honey? Grace, go ahead. 50% is right. Okay. 56 is our median. Okay, more than that is 50. What percent of hives brought in 63 pounds of honey? Jack, go ahead. 25%. Awesome. Good. How many of you did get this? Correct. Good. All right. And then you guys have this on the next page. Okay. So we're looking at Chicago and San Diego. What was the median for Chicago? Liam.
36.2.
Median. 36.2. Good. San Diego. Cece. 10.3. Good. Okay, which city has had more? Sawyer, go ahead. Chicago, good. Okay, what percent in San Diego is above 8.1? Diane? 75, good. Okay, what percent of the time did Chicago have at least 40.1 inches? Sabrine? 25, good. Okay, what is the IQR in San Diego's box plot? Danielle? Okay, it's 12.8 minus 8.1. Okay. I know, just 12.83 for San Diego. What? Oh, it looks like 12.3. It's 12.8. Yeah. It could be any one of those. Yeah. That's why, like, anyway, pulling graphs from different texts, it doesn't. I have to make my own little, making a note, make my own little numbers so you guys could see them better. This happened more than once this year. So anyway, what city has a higher quartile 3? Braden. Chicago, good. Okay. So, is it more common to have 32 inches in Chicago or over 3.7 in San Diego? Genevieve. Perfect. Or 3.7 San Diego. It's 100%. Awesome. Good. All right. And the last few. Okay. What is the third quartile shown in the box and whisker? Let's see. Jackson, what do you think? 10. Okay. For number 2, what percentage of the test scores are less than 72? Emma? 25. Good. All right. So again, pretty straightforward, okay, in terms of visual representation of data. The majority of you did participate, so thank you. Okay, that's the most I would say in all 3 of my honors classes that do participate, so nice job. Okay, with that. With the homework, I want you to look at number 7. A lot of you had questions or question marks near it. No, we'll go from there. All right. Anytime you knew how to do the box and whisker, you just were not sure what the shape, center, and spread met. Okay, so we're just going to clarify here, so you might want to jot some things down as we go through it. Okay, so anytime it's asking for shape, your options are symmetrical, skewed left, or skewed right. Okay, these are your options in terms of shape if it's asking for shape. Okay, then if it's asking for center, okay, if it's asking for center, you're either going to look at the median or the mean. If it's skewed, which one are we looking at? What would be a better representation? Nolan? The median. If there's outliers, the median is the most that we would look at, okay? The median would be what you describe the center as for box plots, okay? So the median and mean are the center. This is with outliers or if it's skewed, okay? Mean you would typically use if it's a normal distribution, okay? And the last one is spread, okay? Some things, 3 things we could use to describe spread. Number 1, IQR. The IQR, the interquartile range, is paired with the median, okay? And that's only for our box plots, okay? The other type of spread is our range, okay? And the last one is our standard deviation, okay? Standard deviation looks at a graph as a whole, okay? So, what's up? Yep, you could just go. All right, so shape are one of these 3 things, okay? You could even elaborate on the shape in terms of mean and median. You could elaborate that way. The center is the median and mean, okay? And the spread are those 3 things. So anytime it's asking you to describe those 3 things, that's what you would use, okay? Those are some keywords. Does that make sense? The spread talks about the variability, so you could act on that too. All right? Questions, comments, concerns? All right. In your notes, turn to page 17. Turn to page 17. All right. So this is the last lesson, okay, in the statistics unit. Told you it was very quick, just like probability. This is more on describing, okay? So you have some words here. You have the population, which is the entire set. So the population, let's say, is all Fairfield Ludlow students, okay? That is the population. The population can be all adults, all Americans, blah, 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 okay? The sample is a part or a piece of the population. So if our population is all Ludlow students, a sample could be juniors. A sample could be Warner House. A sample could be this class, okay? So it's a part of the population, okay? So the bigger the sample and the more random, the more accurate you will be, okay? So that's most important, okay? You're sampling, the larger it is, the better it is, okay? Because it reduces on some errors that could occur, all right? So we have 2 examples here. We're just going to look at what the population and what the sample is, all right? The God bless you. Probability in stat class is doing a study on how many hours students at Ludlow spend on TikTok during one day. They poll one class of each grade and collect their data. Very straightforward. What is the population? So what is the big picture? What's that? Good. Students at Ludlow. Good. Okay. What would the sample be? Danielle? Yep. One class per grade. Okay. Plain and simple. All right. Now, number 2, your wrestling coach wants to sign up his team for a tournament over the first weekend in March. He polls the seniors to see if they are available before asking the whole team. What is the population? Addison? Good. Okay. Population is a wrestling team. What is the sample? Liam? Yep. Okay. So the whole idea in terms of why we use sampling, okay? How many of you have heard of the census before? Okay. Oh, wow, a lot more than my last class. The census is run how often? Every 10 years, because it's very expensive to run, okay? Your parents or even maybe yourself have received mailings, phone calls. They just ran one not too long ago, okay? Mailings, phone calls. Half the time if they call, we hang up, some of us that don't want to talk to them, you know. Very rude, but whatever. Because they ask questions about the population, where you live, how many, what's your income, blah, blah, blah. All this type of information to gather about the population, okay? That's a lot of people, okay, to run the census. That's why it's every 10 years, because it's expensive. But it's also kind of impossible to run and get an accurate piece of data based on the whole entire population, okay? It's very difficult to do so. That's why we sample, okay? Sampling obviously has its own errors, but the sample makes an inference about the population. That's the whole idea behind it, okay? So we addressed the who. Now we have to look at the what, okay? So why are we doing this? Well, you have 2 new words here, parameter and statistic, okay? So a study begins with asking a question that can be answered by data, okay? Population summary measures are called population parameters, and a sample summary are called statistics, which is a lot of the information we receive on a daily basis, okay? So examples include a total, gross movie receipts, a mean or an average, the proportion, the percent. Those are some key words we will hear. And they're going to be very similar for both parameter and statistic, okay? So, therefore, the data you gather from your population is your parameter. The data you gather from your sample is your statistic, okay? So, SNS and PNP. All right? So, often it's hard to measure, which we just talked about the whole population, or actually get a numerical value that represents the population. It's very difficult to do that. Some cases you will be given it, but others you kind of have to use different wording to describe what you're trying to measure. So percent of people, average time, it's going to be the same wording and or specific value for the statistic. So if the parameter says average time, my statistic is going to be the actual average time. If it says percent of, the statistic will be a percentage of something that you're measuring. Does that make sense? So it's not that difficult. It's just keeping the words consistent. Okay? So example 1 is a very reliable source, clearly. Okay? Snapple.com, very reliable. Okay? 13% of U.S. adults are left-handed. At a school's administrators conference, 16% of adults attending were left-handed. Well, the population is all adults in the U.S., correct? A piece of that population were adults at an admin conference, okay? Now, looking at the parameter of all adults, they gave us this information. So that represents all. The statistic, however, is 16% of this sample, okay? So if you notice, is the wording the same? We have a percent here, both saying left-handed. This is all adults, and this is just adults at blah, blah, blah. So the wording is going to be very simple, very similar, okay? So let's look at this example where the parameter is unknown, okay? So a random sample of 300 Ludlow juniors were asked when they went to bed during the school week. 85% of these students went to bed after 11, okay? So what is the population? Let's start there. What is the population? Braden. Even a little more specific, we could. Yep. Because they're specifically doing this survey regarding juniors. Okay. What is the sample? Assad? 300. And you can include random there. Doesn't matter. Okay. So right now, looking at the sample and population, same wording, right? One says all and one says a piece. Okay. So now, before we get to the parameter, looking at this statistic is what? Danielle? Okay. So, based on that statistic, and you can include 85% of 300 juniors or 85% of the random sample. That could be included. Okay. The parameter is we don't have a numerical value to represent the parameter. So we are going to replace a number with the percent of juniors go to bed after 11 p.m. Or who went to bed. Could include. Okay. So again, same wording. This was the unknown though. The parameter about all Ludlow juniors, we're making a general statement. The percent of. Okay. So let's look at sample number 2. Or the first one that you're supposed to try, but Miss Betta wants to know if any students missed her during quarantine. She posed one of her classes, asked if they missed her, and 74 say that they do. Okay, so what do we got? Give me one thing, Nolan. Thank you. Good. What's next? What else do we know? Addison. Good. Okay. What else? Go ahead, Rosanna. Yeah. Okay, I elaborated a little more for now, just so you could see similarities. Okay, in some cases you might see that say 74%. Yeah, Nolan. Sure, go ahead. Perfect. Good. The percent of typically the wording will be given to you in the actual scenario. Okay, so typically this would be included, or it actually might tell you literally what the parameter is, the average of, the percent of. It will definitely tell you that. Okay, try the next one on your own. All right, your group of friends want to record how many ounces of water they consume during the day. 3 of the friends record their water consumption and learn they consume an average of 38 ounces a day. As a group, they also record and learn that on average they consume 43 ounces. All right, what do we know? Someone else who hasn't answered. Which is only a bare minimum. Yeah. Yeah. Good. Group of friends. What else? Caitlin. Yep. Great friends. Good. What else? Go ahead, Louise. Good. Okay. And what else? Breen. Okay. And again, some might elaborate, meaning the 3 friends found that 38 ounces a day was the average. You know, something along those lines. Some might elaborate. Some might just give statistic was 38 ounces and the parameter was 43, because you could always tie it back of who you were measuring. Okay, does that make sense? Okay. All right. Now the next thing is something that we hear on the daily, okay, in terms of sampling. So the margin of error, okay, also called the MOE, it's the likely error when data from a sample, okay, are used to estimate a population characteristic. So anytime we're sampling, we're inferring about the population. That's point blank. That's what we're doing. Okay, the margin of error tells us how close our estimate is to the true parameter. Okay, so we're trying to get as close as we can, but that's not always the case. What are some things that can happen in terms of sampling? What can go wrong? Let's start with that. What can go wrong with sampling? What are a few things? Yeah, Nolan. Good. Okay. What else? What else can go wrong? Yeah. Correct. Okay. What else? Yeah. Okay. What else? Think of, you guys have seen probably in homerooms maybe the prob and stat class coming in and doing surveys. Some might. Yeah. A lot. A lot. Yes. Okay. So what are some things that can go wrong there? Like not everybody answered, but I believe their population was everyone in the school. So right then and there, they're not getting probably a big sample, maybe, who knows? You guys see that, right? I'm not going crazy? Okay. If I draw that thing would be lighting up. Okay, anyway. So some of the sampling could be the way the question's asked. Can people not be truthful when they answer these things? Yeah. Maybe lie. People do that. Okay. There's a whole bunch of things. So that's why we do this margin of error. Okay. It creates a buffer, right, of what can go wrong. All right. So anytime we're figuring out the margin of error, all right, we use this shortcut formula, which is 1 over the square root of n. N meaning your sample size. Okay. N meaning your sample size. And it's plus or minus. It's very similar to how we figure out the standard deviation. We take our statistic, we subtract the margin of error, and we also add and get a new interval. Okay? That interval okay, will be called the confidence interval, and I'll get there in a minute. Key piece of information. Larger the sample size, the smaller the margin of error. Smaller the sample size, larger margin of error. So a lot more stuff can go wrong. It won't be accurate. Okay? So the confidence interval. Some of you have heard, you might have, I don't know if you do, that on news or any social media, we are 95% confident that. Have you heard that statement before? Okay, that means it's the confidence interval, okay? It's letting the reader know how certain we are, okay, for that estimate. So what it does, it gives you your statistic in a range. It gives you a range to create a buffer of something going wrong, that we want to be close to that percentage. That's why we always make this interval of 95% confident to prove our case. All right. So we have this poll that was taken. Okay. Found that 35% of Americans got their most recent news from social media. The survey asked 2,078 adults in the U.S. questions about their media consumption. 95% confidence was given for the conclusion. Okay, so what is the population? Nolan. American adults. Good. Okay. What is the statistic? Do you know? Good. 35%. And people were questioning that in the other class, but it's the poll that was taken of the 2,000 plus adults. Okay. What is the sample size? Louise. Excellent. Okay, so now we're going to find the margin of error. Okay, this is the quick method to use it. So it's 1 over the square root of 2,078. What would it be as a decimal? Round to the 3 places after the decimal. What do we got? Louise, go ahead. What is it as a decimal? Yep. 0.022. Okay, 0.022. 1 over the square root of 2,078. So as a percentage, it's the plus or minus 2.2%. Okay, you have to remember anytime you're talking about the margin of error, you must include plus or minus. Okay, because we also took a square root. All right, so the confidence interval, how we set this up first. Wait, bless you. Take our statistic, 35, and it's plus or minus 2.2%. Now that's our interval. Okay, you could also do it out, which we're going to see in our statement. Okay, the conclusion, we are 95% confident the percent of Americans getting their news from social media is between what? How can we figure this out? What do we do? Brayden?
We add the 35, which would get us 33 to 37.
Roughly, right? So, because it's the 2.2. So 35, we minus the 2.2 to get 32.8%. Then we add it. Okay, so it's 35 minus 2.2, 35 plus 2.2. Okay, so this right here, our conclusion is our confidence statement. Anytime it's asking for the interval, you can write it just like that. Okay, let's try a few more.
Where does the 95% come
That's always between, they give you a level of confidence between 90 and 100, meaning you're really, really close to the truth. 95 just dead center, that you are pretty sure that this is the right amount, okay? When you guys take, if you take higher statistics classes, you're going to do different confidence levels all over, all right? Okay, so a survey reported 16.8% of the population smoked with a margin of error of 3.2%. What is the actual range of the probable values? Okay, what do we get? Same people keep answering, so who else? Caitlin. Perfect. We take a 16.8% plus or minus the 3.2. So the actual range is the 13.6 to 20%. Okay? So, what are some reasons why we have a range and not just a single percent? What are some things? Go ahead, Liam.
I think it has to take its consideration after 2% margin of error. So to either add 2.2% or subtract back 3.2% to represent that range of potential other results. That was just the raw statistic.
So why do we have a range instead of just one percentage? So say, why can't it just be 16.8? Why does it have to be a range?
Every value has to be considered.
Okay. Okay. Nolan? Sample? Good. Anything else? Does a single percentage mean that it's definite, that that's it? Right? 16.8% means we're absolutely certain that the population smoked. Okay? 16.8%. If we're giving one percentage like that, we are certain we have no errors. We've done everything right. Correct? But we're sampling. So there has to be some sort of, let's say, wiggle room, okay, to be close to the truth. Okay? There's got to be something. Right? We have to give a range than an actual percentage. An actual percentage means definite, and we are 100% certain. Make sense? Okay. So in number 3, this works backwards. They're giving us the range, which we just found. Okay, they're giving us the range between 540 and 600 on the reading and writing section of the SATs. How can we figure out the estimate? Nolan? The middle of the two numbers, right? Which would be what? 570. Rosanna, was that right? Good. Okay. It's the average of the interval. So you have 540 plus 600. You could divide by 2 or actually just figure out what the middle is. Okay. Then what is the margin of error then? 30. Okay, so here we're just working backwards. They gave us the interval, so now we're just dissecting it basically. So the estimate is 570 plus or minus 30. Okay, so again, we just worked backwards there. Okay, so now this I believe is the last one. All right, so again, we're back to polling. You broke up participants into 2 groups. Okay, asked both if they were bothered by seeing other people not recycle. Okay, group A had 438 people. Group B had 191. If 61% of both groups answered yes, so that means group A, 61%, group B, 61% answered yes. Okay, it's not all together, they're both separate. Answered yes, they were bothered. What is the confidence interval for group A? What do we think? What is the confidence interval for group A? Okay, what is the confidence interval for group A? Well, we know the statistic, which is what? 61. Okay, what is the sample for group A? Yep, 438. Good. Okay, so how can we figure out the margin of error for group A only? Sawyer, how'd you get it? 1 over the square root of 438. Good. We end up with plus or minus 4.8%. So that interval would look like what? 61 plus or minus 4.8%. So then, if we are using group A, we are 95% confident the true proportion of Americans would be bothered by seeing other people not recycle is between what? Sabrine? You're going from this one. It's okay. It happens a lot, believe it or not. The 95 is just a standard, 95% confident. Okay, Danielle. Good. Good. Okay. So again, anytime it's saying the between and you're giving an interval, it goes from that. Okay. Try group B. Yeah. Find group B. 7.2%. Good. So 1 over, what was the sample size? 91. It was 7.2%. Okay, 61 plus or minus 7.2%. So, yeah. And she gets back. So, actually, if you answer this. So, we are 95% confident the true proportion of Americans would be bothered by seeing other people not recycle is between what? Yep. Good. Okay. So, which group is more useful and why? Go ahead. Excellent. Okay, so you guys just saw the difference between larger sample size, smaller margin of error. Okay, small margin of error, we had a larger, small sample size, we have a larger margin of error. Okay, so group A is more useful because larger the sample size. All right. All right, so that concludes our stat unit. Okay, again, very short and sweet. Your homework is in the green packet. 4.3 practice all. But 9 and 11, I think, are the same questions, so just do one of them. This starts on page 10. Okay. Starting on page 10.